Low-thrust propulsion is essential for all space missions, and NASA's Lewis Research Center is conducting programs to provide a broad range of low-thrust propulsion concepts for these auxiliary and primary functions. Auxiliary propulsion basically is used for keeping space systems in desired locations or for orientation. Typical examples are the reaction control systems for Earth-to-orbit vehicles, drag makeup and attitude control for low Earth orbit systems, such as the space station Freedom, station keeping for higher orbit systems, such as geosynchronous satellites, and then retro functions near planetary bodies. Primary propulsion functions include the moving of space vehicles from point to point in Earth space, as well as propulsion from Earth space to various planetary bodies. On Earth-to-orbit vehicles, such as the Shuttle Orbiter, low-thrust propulsion systems are used to control the orientation of the vehicle. Examples would be to control the movement of the Shuttle Orbiter to face the Sun, or reorient it to meet other specific requirements, and then to deorbit the shuttle for its return to Earth. The low-thrust devices used for these applications are called reaction control systems. For use on the space station Freedom, two different kinds of low-thrust propulsion systems have been selected. For drag makeup, thrusters called resistojets will be used. These resistojets will use the waste gas from the various space station modules. This approach eliminates the requirement for the launch of drag makeup propellant and the return of waste gases. For the attitude control of the space station, Lewis is working on small chemical rockets. These engines are used to control the torques and forces that are created during shuttle berthing and other situations where moderate thrust levels are required. High Earth orbit systems need two very different kinds of auxiliary propulsion systems. First, when geosynchronous satellites are placed into orbit, an apogee propulsion system is required to circularize the satellite and place it into the correct orbit. The geosynchronous orbit is the one that makes the satellite appear to be in a fixed position when viewed from the Earth. In order to keep the satellites in desired orbit, NASA Lewis is working on very low-thrust electric rockets called arc jets. A final example of auxiliary propulsion is the use of chemical rockets near planetary bodies. It is necessary to provide a retro-propulsion maneuver at planetary bodies so they may be captured and allow the spacecraft to go into orbit around the bodies, or simply to slow down to obtain desired data. Primary propulsion is being developed for use in both Earth orbit and for planetary missions. Planetary missions include the transfer of systems to beyond Earth space, to such targets as planets, comets, and asteroids. In summary, then, all space missions use low-thrust propulsion in one form or another. The Lewis Research Center is conducting a low-thrust propulsion program utilizing an in-house, university, and industrial team. This blend of skill and capability assure that the program will develop practical devices for near-term applications and at the same time produce more advanced concepts for the longer-term, higher payoff national space missions.